Sanjay Kumar. He completed his BE Civil Engineering from Madurai Kamaraj University. He also pursued his ME Soil Mechanics and Foundation Engineering from Anna University, Chennai. He worked as a designer engineer for 1 year under a structural consultant in Madurai. He is currently working as a faculty member in the Department of Civil Engineering, Tyagarajar College of Engineering, Madurai. He has organized 2 national conferences at TCE in 2010 and 2014. He's also got 3 publications in international journals. He is an A-lead member for the Geotechnical Consultancy at Tyagarajar College of Engineering.
Welcome to UGC lecture series on architecture. Subject name is Mechanics of Structures 1 and we are in unit 3, which is properties of sections. This will be lecture number 7. Contents of this lecture will be as follows: center of gravity and centroid, center of gravity of plane geometrical figures and solids, locating the center of gravity of plane figures by method of moments, and finally we will be seeing the moment of inertia of areas. Now let us see the meaning of center of gravity. Center of gravity is the point through which the entire weight of an object acts irrespective of its position. Generally, center of gravity is written as CG. A body has only one center of gravity. Now consider this object. Now this particular object will have its center of gravity. Through this center of gravity, the entire weight of this object acts in the downward direction. W is the weight of this object. Through the center of gravity, the entire weight of this body or object acts in the downward direction. Now if we change the orientation of this object, say like this, I am drawing the same object, but in a different orientation. Even if the orientation of the object is changed, center of gravity will not shift or it will not be at some other point. Center of gravity will be remaining same. So always through the center of gravity of an object, its entire weight will be acting in the downward direction. So it is a point through which the entire weight of the object acts in the downward direction irrespective of its position. Also a body will have only one center of gravity. Centroid is slightly different from center of gravity. Plane geometrical figures like rectangle, triangle, trapezium have areas but no masses. Center of area of such figures are known as centroid. Now the difference between center of gravity and centroid is that center of gravity indicates the center of mass of solid objects or 3-dimensional objects, whereas centroid is the center of area of 2-dimensional plane figures like square, trapezium, circle, etc. So consider this to be a circular plane section of certain diameter. Now area of this circular section will be pi by 4 into d square. Center of area of this plane circular section will be its centroid. So here the point G denotes the centroid of this circular section. But in general, both center of gravity and the term centroid will be used in conjunction. There is nothing wrong if you use the term center of gravity even for plane geometrical figures. Now let us see about axis of reference. Generally the position of center of gravity of plane figures or centroid of plane figures are calculated with reference to some assumed axis. For plane figures, reference axes are taken as the lowest line and the left line of the figure. Now consider a square section. Center of area of this square section will be its centroid or center of gravity. So CG is the center of gravity. Now generally the position or coordinates of the center of gravity will be given with respect to some reference axis. The reference axis will be the lowest line of the figure. So this is the lowest line of the figure, or we can call it as x axis, and the left line of the figure, this is that particular line, left line of the figure can also be indicated as y. So these two are reference axis, that is x axis which is the lowermost line and y axis which is the leftmost line of the figure. So, position of the center of gravity of this object will be found out with respect to these two reference axes. Now, we shall see how to locate center of gravity of plane geometrical figures. Now, first of all, we shall consider a square section. A square is a two dimensional plane figure. Let the side dimension of the square section be A. For a square section, center of gravity is the point where the two diagonals of the square intersect one another. So, this is one diagonal and this is the other diagonal. So, CG is the point where the two diagonals are meeting. So, this will be the CG. For a rectangular section also, center of gravity will be the point where the two diagonals of the rectangle are going to intersect. Now, we shall come to a triangular section. Let the base width of the triangular section be small b and the height of the triangle section be h. For a triangular section, center of gravity is the point where the three medians of the triangle are going to intersect. Median is the line which is drawn from the apex of the triangle to the midpoint of the opposite side. Let us name the corners of this triangle A, B and C. So, the first median will be from C to the midpoint of AB. So, this is that median. Another median will be from the corner B to the midpoint of AC, and the third one will be from A to the midpoint of BC. So, these are the three medians. Center of gravity will be the point where the three medians are going to intersect with one another. Now, center of gravity for this triangular section from the base will be at a distance of h by 3. Remember, h is the altitude or height of the triangle and the distance of the CG of this triangle from its base will be h by 3. Similarly, for the previous square section, distance of the CG from the base, it should be naturally a by 2. Similarly, distance of the CG from the left line will also be a by 2. This is for a square section. Now, let us locate the center of gravity of a semicircle. Now, this semicircle has a diameter of small d. Now, this dot represents the midpoint of the base of the semicircle. CG of this semicircular section will be located at a height of or at a distance of 4r divided by 3 pi right above the midpoint of the base of the semicircle. So, this is the CG. Distance of CG from the base will be equal to 4r by 3 pi and the CG will be right above the midpoint of the base. Now, let us consider a trapezium. A trapezium will have two sides parallel to one another. Now, let B be the dimension of one of the parallel sides of the trapezium, then the dimension of the other side, other parallel side of the trapezium be small a. Let the distance between the two parallel sides of the trapezium be h. This will be the CG of the trapezium. Distance of CG from the base will be equal to h by 3 into b plus 2a divided by b plus a. So, this is the distance of CG of the trapezium from the base being the longer side. Now, let us see how to calculate or how to locate the center of gravity of plane geometrical figures by method of moments. Consider this lamina. Now, our aim is to locate the center of gravity of this laminar figure with respect to this x and y axis. That is, we need to find out the coordinates of the CG of this laminar area with respect to x and y axis, for which we are going to adopt this method. This method is known as method of moments. What we have to do? We have to split this laminar area into numerous small strips of much smaller area. Now, here I have shown two smaller subdivided areas along their own center of gravity. Now, let the distance of center of gravity of, so this will be the first area and this will be the second subdivided area. Let the distance of center of gravity of the first subdivided area from y axis be x1. Likewise, let the distance between the CG of second area, small area from y axis be x2. Now, like this we will be having n number of small strip areas. Center of gravity, distance of center of gravity of each and every areas from y axis will be x1, x2, x3 up to xn. The distance of center of gravity of the first area from x axis be y1 and the distance of center of gravity of the next area, that is second area, from x axis be y2. Likewise, we will be having distances up to yn. So, we have divided the given laminar area into numerous small strips and we have found out the coordinates of the center of gravity of each and every divided small strips. So, x1 comma y1 will be the coordinates of the center of gravity of the first strip. Similarly, x2 comma y2 will be the x and y coordinates of the CG of second strip. Likewise, we will be having n number of small strips. The nth strip will have coordinates of xn comma yn. Let the x coordinate of the CG of the whole figure be x bar and the y coordinate of the CG of the whole figure from x axis be y bar. So, coordinates of the CG will be x bar comma y bar. So, these two coordinates x bar and y bar have to be determined. X bar will be equal to a1 x1 plus a2 x2 plus up to an xn divided by sum of all the individual areas of the strips a1 plus a2 up to an. So, here a1, a2 etc. are areas of the divided small strips. Likewise, we can get the y coordinate of the laminar area. Y coordinate of the CG of the laminar area will be a1 y1 plus a2 y2 plus up to an yn divided by sum of the areas of all the strips a1 plus a2 up to an. Now, this method can be adopted to locate the center of gravity of areas other than conventional geometrical plane areas like square, rectangle, trapezium etc. Now, we shall see a problem for locating the center of gravity of an unequal angle section. Now, these type of angle sections will be used for the members of trusses and also as column sections. Now, the dimensions of the unequal angle sections are given in the figure. One leg of the angle section is 8 centimeter wide and the other leg is 10 centimeter wide. Thickness of both the legs are 3 centimeter. We are asked to determine the position of center of gravity of this unequal angle section, for which we are going to adopt method of moments. Let me draw the same angle section here. if you see this unequal angle section, it is a combination of two rectangles. So, we shall split this angle section into two rectangles by drawing a line like this. Now, we have got two rectangular section. Let us number the rectangular section. This will be rectangle number 1 and this will be rectangle number 2. Now, as we discussed before, CG will be located with respect to the reference axis. The reference axis will be the bottommost line of the figure, which will be the x axis, and the left line of the figure, which will be the y axis. Now, rectangle 1 will have its own CG. The dot which I am marking here represents CG of rectangle number 1. Now, we shall consider the first rectangle. Area of the first rectangle will be 8 into 3, which will be 24 centimeter square. The y coordinate of CG of rectangle 1 from x axis will be y1. So, this distance will be y1. So, the distance y1 will be from the x axis up to this bottom level, the distance will be 7 centimeter. From x axis up to the bottom of this particular horizontal leg will be 7 centimeter. Thickness of the leg is 3 centimeter. So, this distance will be half of 3. So, y1 will be 7 plus 1.5, which will be 8.5 centimeter. Now, we shall come to the second rectangle, which is rectangle number 2. Area of rectangle 2 will be, now the length of the rectangle will be, rectangle 2 will be 7 centimeter, cross its width will be 3 centimeter. So, area will be 21 centimeter square. Now, this rectangle 2 will have its own CG. This dot which I am marking here is the CG of rectangle 2 alone. Distance of CG of rectangle 2 from x axis is y2. So, this distance is y2. So, y2 will be half of 7, which will be equal to 3.5 centimeter. Now, we shall calculate the value of y bar. So, y bar distance will be a1 y1 plus a2 y2 divided by sum of the areas a1 plus a2, which will be 24 into 8.5 plus 21 into 3.5 divided by sum of the areas, which is 24 plus 21. So, the answer will come as 6.167 centimeter. Now, we shall calculate the value of x bar. Now, this is rectangle 1, its center of gravity is here. Distance of center of gravity of rectangle 1 from y axis is will be denoted as x1. So, distance x1 will be 8 divided by 2, which will be 4 centimeter. So, x1 will be 4 centimeter. Likewise, we shall get the value of distance of center of gravity of rectangle 2 from y axis, which will be x2. So, this distance will be x2. So, x2 will be equal to half of 3, which will be 1.5 centimeter. X bar will be calculated as a1 x1 plus a2 x2 divided by a1 plus a2. a1 is 24 into x1, x1 is 4 plus a2 21 into x2, x2 is 1.5 centimeter. This whole divided by sum of the areas 24 plus 21. The answer will be coming as 2.833 centimeter. So, x bar for the figure will be 2.833 centimeter and y bar for angle section will be 6.167 centimeter. Now, we shall see the meaning of moment of inertia of plane areas. Now, consider a plane area like this, and also consider a reference line. Now, we are going to compute the moment of inertia of this plane area with respect to this reference line, which is AB. What we are going to do, once again we are going to divide this given area into numerous smaller areas, smaller strips. Here I am showing only 3 strips. The entire area will be divided into strips. Now, this dot represents the center of gravity of the first strip, and the second dot is the center of gravity of the second strip, third dot is the center of gravity of the third strip. Now, the distance between the center of gravity of the first strip from the reference line AB is R1. Similarly, R2 be the distance between the CG of the second strip from the reference line. Likewise, R3 is the perpendicular distance between CG of the third strip from the reference line. Likewise, we will have distances up to Rn. Now, moment of inertia of the given plane figure of the laminar area about the reference line AB will be given by I suffix AB. Moment of inertia will be denoted by the alphabet capital I. So, IAB will be equal to A1 into R1 square plus A2 into R2 square plus up to AN into Rn square. In the above equation, A1, A2 up to AN are the areas of the small strips, the divided small strips. From the equation for the moment of inertia of this plane area, we can say that moment of inertia is the second moment of area, because moment of inertia is summation of A into R square, where A is the area of the divided strips and R is the square of the perpendicular distance between the CG of the divided strip from the reference line. So, in a simpler term, we can say that moment of inertia of area is the second moment of area. Moment of inertia of areas will have the following units. It can be represented in centimeter power 4 or millimeter power 4 or meter power 4. Now, we shall see how to Mi is moment of inertia of areas by integration. Consider a laminar figure. Here the reference axis are x axis and y axis. In the previous case, the reference axis was AB. Now, here the reference axis are x and y axis. Now, we are going to consider a small strip area within this laminar figure. This strip will have its center of gravity. So, this particular dot represents the center of gravity of the strip area. Let the distance of the center of gravity of this strip from y axis be small x, and the distance of the center of gravity of this strip from x axis be small y. Moment of inertia of the strip, that is the small strip, about x axis, you can call it as x axis or you can call it as xx axis. Moment of inertia of the strip about x axis will be given by dA into y square, where dA is area of the strip. So, this is the moment of inertia of the strip alone with respect to x axis. We can calculate the moment of inertia of the whole laminar area of the whole figure about x axis. So, moment of inertia of the whole figure about x axis Ixx will be given by summation of dA into y square. Likewise, we can get the moment of inertia of the whole moment of inertia for the whole area about y axis or y axis, which will be Iyy. Just like the previous case, it will be summation of dA into x square. We can summarize the things which we have discussed in this particular lecture. We have seen the meaning of center of gravity and centroid. We have seen the procedure for locating the center of gravity for regular plane geometrical figures, and also we have seen the method for locating the center of gravity by method of moments. Also, we have seen moment of inertia of areas. Students can answer these questions. What is the difference between center of gravity and centroid? Second question is a problem. Locate the center of gravity for the T section shown below. So, the dimensions of the T section are shown in the figure. With this, we have come to the end of this lecture. Thank you.